Hello, and welcome to part 2 of our lesson on algebraic expressions. If you missed part 1, make sure to go back and watch that first so you can have a good foundation to build on. Today, we are going to discuss how to evaluate algebraic expressions and apply them to real-life situations. Ready? Let's go! When we try to evaluate an algebraic expression, we try to find the value of the expression by replacing the variables with a given number. After the variable is replaced by a number, we evaluate the expression using the order of operations. Let's take a look at how we can evaluate one such algebraic expression. Consider the expression 3x plus 7. Let's find the value of this expression in two different scenarios. Change the value of x. We'll try x equals 5 and x equals negative 1. Let's start with x equals 5. To evaluate, replace x in the expression with the number 5 and then simplify. After plugging in 5 for x, we need to multiply 3 and 5 together, which gives us 15. This leaves us with 15 plus 7. We can now add 15 and 7 to get 22 as our final answer, which is the value of the algebraic expression. When x equals 5, the expression 3x plus 7 has the value 22. When the value of x is changed, the value of the expression will change too. Let's do x equals negative 1. First, we replace the x with negative 1, and we multiply the 3 and negative 1, giving us negative 3. We are left with negative 3 plus 7. When we subtract their absolute values, we get 4. Remember, the result is positive because 7, the larger number, has the positive sign. Therefore, when x equals negative 1, the expression 3x plus 7 has the value of 4. Now that we have learned what it means to evaluate an algebraic expression and the steps to do it, let us take a look at some different examples. For the first example, consider the algebraic expression a minus 15. Let us evaluate this expression for two different values of a, the first one being 17 and the second one being 13. When a equals 17, we can replace a by 17 in the given expression a minus 15. This would give us 17 minus 15. Simplifying this would give us 2 as the final answer. When a equals 13, replace the a by 13 in the expression. This would give us 13 minus 15. Observe that in this problem, the larger number has a negative sign. So, 13 minus 15 gives us negative 2. When a equals 17, the value of the expression a minus 15 is 2. When a equals 13, the value of the expression is negative 2. Take a look at the next example, which has two variables. In this expression, we have two variables, x and y. To fully evaluate this expression, we need to know the values of both the variables. Here we are told that the value of x is 7, and the value of y is 8. Evaluating the expression would follow the same steps as before. We start by replacing the x with 7 and the y with 8. Now, we need to multiply the 5 and 7 to give us 35 in the first term. The three terms of this algebraic expression are now reduced to 35 plus 8 minus 2. We can now simplify this using the order of operations. Note that the plus and minus signs appear in the same line. According to the order of operations, we need to go from left to right, so the addition needs to be performed first, and then the subtraction. Adding 35 and 8 gives us 43. Subtracting 2 from 43 gives us 41. So our final answer is 41. Therefore, the value of the expression 5x plus y minus 2 when x equals 7 and y equals 8 is 41. Let us move on to the third example. In this case, we have a variable with an exponent. Here, 3x squared means 3 times x times x. First, we substitute 2 for each x. 2 squared simplifies to 4. Next, we need to multiply the 3 with 4 and the 4 with 2. This gives us 12 and 8 in the next step. At this stage, the expression has reduced to 12 plus 8 minus 1. We can now simply apply the order of operations to get 19 as our final answer. Therefore, when x equals 2, the value of the expression 3x squared plus 4x minus 1 is 19. For the fourth example, let us look at an algebraic expression with 3 variables. If this algebraic expression looks really long, don't worry. All we need to do is follow the steps of the simplification that we have learned so far, and we'll be done in no time at all. This algebraic expression has 3 variables, x, y, and z. The given expression is in the form of a fraction, with x plus 3y squared plus 3 forming the numerator, which is the top part of the fraction, and 10 minus z being the denominator, which is the bottom part of the fraction. We can evaluate each of these parts individually to find the value of the entire expression. Let's begin by substituting the values of the variables in the expression. Substitute 5 for x, 3 for y, and 3 for z. In the numerator, we have a term involving an exponent. According to the order of operations, we need to evaluate that first. Here, the term involving the exponent is 3y squared, which is 3 times y times y. After plugging for 3 for y, this particular term would reduce to 3 times 3 times 3, which is 27. Therefore, in the numerator, we are now left with the terms 5, 27, and 3, all of which need to be added together. Adding them gives us 35 as the numerator. While evaluating the numerator, you can also simultaneously evaluate the denominator. Plugging in 3 for x in the denominator gives 10 minus 3, which reduces to 7. Therefore, the value of the numerator is 35, and the value of the denominator is 7. Dividing 35 by 7 gives us 5 as the final answer. Therefore, the value of the algebraic expression x plus 3y squared plus 3 divided by 10 minus z, when x equals 5, y equals 3, and z equals 3, is 5. Whenever you come across an algebraic expression which is the form of a fraction, you may choose to evaluate the numerator and denominator separately, and then complete the division in the final step. Alternatively, you could work out the values of the numerator and denominator simultaneously as illustrated in the steps below. The final value of the algebraic expression would stay the same regardless of the method followed. Feel free to use any method which you find convenient. To understand algebraic expressions with fractions a little bit better, let us take a look at a similar example. 2 to the power of x divided by y minus z. When x equals 5, y equals 7, z equals -1. This particular algebraic expression has 3 variables once again, x, y, and z. Let's begin by evaluating the numerator and denominator separately. In the numerator, you have a term with an exponent. However, it is the variable x, which is the exponent here. Plugging in 5 for x gives us 2 to the power of 5, which basically means 2 times 2 times 2 times 2 times 2. In other words, 2 is multiplied by itself 5 times. Let's evaluate this in a few steps. We can start by evaluating the first 2 2's, and the second and the third 2's. Hence, the next step can be written as 4 times 4 times 2. This expression is a little easier to work with because we have fewer terms. Proceed to the next manner by multiplying 4 times 4, which would give us 16. Finally, multiply the last 2 with this 16 to get 32 as the final answer. Keep in mind that in the numerator, we just need to multiply 2 with itself 5 times. The order in which we carry out the multiplication does not matter in this case because we are working with just one particular operator, which is the multiplication. You can also choose to multiply the first 3 2's together and the second 2's together, and you will still obtain the same result. We can now move to evaluate the denominator. Here we have 2 variables, y and z. Plugging in 7 for y and -1 for z gives us 7 minus -1. While going over the order of operations, we had learned that 2 consecutive negative signs change to a positive sign. Hence, 7 minus -1 is simply equivalent to 7 plus 1, which gives us the value of 8. Therefore, the value of the numerator is 32, while the value of the denominator is 8. Dividing them would give us 4 as the final answer. Hence, the value of the given algebraic expression when x equals 5, 7 equals y, and z equals -1 is 4. Let's take a quick look at what the steps look like when we follow the second method of evaluating algebraic expressions with fractions, solving the numerator and denominator simultaneously. After inserting 5 for x, 7 for y, and -1 for z, we have 2 to the 5th power over 7 minus -1. We can continue to simplify by multiplying 2 by itself 5 times over 8. Now we have 32 divided by 8, which is equal to 4. If you look at the steps closely, you can see that we have simply evaluated the numerator and denominator at the same time, instead of working on them separately. In either case, the final value of the algebraic expression is still the same. Remember, the method you choose to follow is entirely up to you, as long as you follow the steps and the order of operations correctly. Let's revisit the first problem with Peter going shopping for his sister's birthday party. If you recall, he bought 5 bags of chips, 2 tubs of ice cream, and 1 birthday cake. We use the variables c, t, and k to express the costs of each bag of chips, each ice cream tub, and each cake. So, the algebraic expression was 5c plus 2t plus k. We now know that a bag of chips is worth $3, an ice cream tub is worth $2, and the birthday cake is worth $15. How much did Peter spend for his sister's birthday? To find out his total expenditure, simply substitute the values of the variables in the original algebraic expression. This would give us 5 times 3, which is 15. So the total cost for chips was $15. There are 2 ice cream tubs for $2 each. So the ice cream cost a total of $4. Finally, there was just 1 birthday cake for $15. Adding up the individual costs would give us the total cost as $34. Let's try another word problem. Lois owns a store which sells musical instruments. She pays the employees $15 for every hour worked and $20 for each sale made. On Monday, one of her employees, Joe, worked 5 hours and sold 4 musical instruments. On Tuesday, Joe worked 6 hours and sold 3 musical instruments. How much did Joe earn during these 2 days? To start this problem, let's take a look at the information we have at the moment. We know that Lois pays her employees $15 for every hour worked and $20 for each musical instrument sold. Because the number of hours worked and number of instruments sold may differ with each day and for each employee, we can denote them using the variables h and s. with H indicating the number of hours worked and S indicating the number of sales made. Joe works at Lois's store. On Monday, he worked 5 hours and sold 4 musical instruments. We can go ahead and calculate the amount of money he made on Monday based on this information. Observe that he worked 5 hours and made 4 sales. We can write this as an algebraic expression as 5H plus 4S, with H and S indicating the hours worked and sales made respectively. We also know that for each hour he would earn $15, and for each sale he would earn $20. We can now substitute these numbers for H and S. The algebraic expression would now look like this: 5 times 15 plus 4 times 20. All we need to do now is evaluate this expression. 5 times 15 is 75, and 4 times 20 is 80. Hence, the total amount of money that Joe makes on Monday is 75 plus 80, which is $155. Good work converting all that information into a meaningful mathematical expression. Let's try the same information we have for Tuesday. Just like the previous part of the problem, we can come up with another algebraic expression to find how much money Joe made on Tuesday. On Tuesday, Joe worked for 6 hours but sold only 3 musical instruments. Pause this video and take a few moments to try this one on your own. Remember to use what we already know. As an algebraic expression, this can be written as 6H plus 3S. We now know how much he would earn per hour and for each sale made. Hence, we can substitute 15 for H and 20 for S, giving us the expression 6 times 15 and 3 times 20. All that remains to be done is completing the evaluation for this algebraic expression. 6 times 15 is 90, and 3 times 20 is 60. Therefore, Joe's total earnings for Tuesday is 90 plus 60, which is $150. That was wonderful! Joe sure must be happy with the money he made so far. But wait, we're not done yet. The problem requires us to find his total earnings over these 2 days. On Monday, he made $155, and on Tuesday, he made $150. To find the total amount of money he earned over these 2 days, we can simply add up the earnings for these 2 days. Adding up 155 and 150 gives us 305. Therefore, Joe earned $305 over the course of these 2 days. Way to go, Joe! Let us take a look at a slightly more challenging example. Stewie is X years old. Chris is 3 times as old as Stewie. Meg is 4 years older than Chris. Express Meg's age in terms of X. If Stewie is 4 years old, how old is Meg? In this problem, we need to convert a word problem into an algebraic expression. While this might seem a little challenging at first, we just need to follow the steps we learned so far, and we'll be done in no time. First of all, we know that Stewie is X years old. Chris is 3 times as old as him, so Chris's age is 3X. Next, we know that Meg is 4 years older than Chris. Therefore, to find Meg's age, we just need to add 4 to Chris's age. This means that Meg's age is 3X plus 4. At this point, we have expressed the ages of the 3 siblings in terms of X. For the next part of the problem, we need to find Meg's age when Stewie's age is known to us. We know now that Stewie is 4 years old. Hence, X equals 4. Chris is 3 times Stewie's age, so his age would be 3 times 4, which is 12. Finally, we know that Meg's age is 3X plus 4. We can now replace the X with 4. This would give us 3 times 4, which is 12. The algebraic expression for Meg's age now reduces to 12 plus 4. We evaluate this to get 16. Therefore, Stewie is 4 years old, Chris is 12 years old, and Meg is 16 years old. Good work converting this word problem into an algebraic expression. In this video, we learned a lot about algebraic expressions. We practiced evaluating these expressions and learned how algebraic expressions can be applied to real-life situations. Algebraic expressions may seem difficult at first, but with practice, you will quickly get more familiar with these problems. Always remember to ask for help when you need it. Thank you so much for watching this video, and we'll see you next time.